the problem sets that we were having the most trouble with, I saw 15 and 17. We're going to do two things. We're going to find the domains of these and the inverse, and then we're going to find the inverse. So let me just share something with you. The domain of this guy is all reals except what? What can't you have? 4. Good. What's the range? I don't know. But maybe we can figure it out. If you switch x and y here, we can get x is equal to 3 over 4 minus y. And if this helps, do x over 1. You know what cross multiplying is, right? So if we cross multiply, you're going to get x times 4 minus y is equal to 3 times 1. And then I get 4x minus xy equal to 3. Let's get the y by itself. So I'm going to add xy to both sides. And you get 4x is equal to 3 plus xy. Subtract the 3. And what do I have left to do? What's y equal to? 4x minus 3 all over x. So what's the domain of this inverse function? What's the domain of it? All reals except what? 0. Can't have a 0. And what's the range of this one? I don't know. But I do know. I do know because when you find the inverse, the domain of the inverse is the range of the function, and the range of the inverse is the domain of the function. So we can put all reals except 4 down here and all reals except 0 here. Isn't that slick? So this is why we do inverses, is because ranges are so hard to find. Here we could find those pretty easily. Are you okay with that? Now I'm going to totally erase that, and we're going to do 17. Same way. What's the domain of 17? All reals except what can't you have? Well, let's see. 3x plus 4 equals 0. 3x equals negative 4. X is equal to negative 4/3. All reals except negative 4/3. How many had that for your domain? If you didn't, you just did the inverse, that's fine, but I just wanted to make this point today. What's the range? I don't know. But we can find it if we found the inverse and we look at the denominator, we can figure out what the range of this is going to be. So here goes. Here's y, here's x. So we're going to switch these, and we're going to say x is equal to 2y minus 1 over 3y plus 4. Oh, I don't know why that's not going here. Cross multiply, and you get x times 3y plus 4 equals 1 times 2y minus 1. Or x times 3xy plus 4x is equal to 2y minus 1. Put the ones that have there we go. Put the ones that have y's together. And the ones that don't have y's, put them on the other side. So I'm going to have negative 4x minus 1 on this side and 3xy minus 2y on this side. Take out a y, and what do you get? 3 x minus 2. And now I can solve it. Y is equal to negative 4x minus 1 over 3x minus 2. And I saw this on a lot of papers. This is the inverse of that. Does that kind of make sense? Okay. Turn to your neighbors, tell them how we got to this point here. And then we're going to find the domain and range in a bit. But go ahead and tell them how you got that far. Go. All right. So now, what is the domain of this thing? What's the domain of it? All reals except what can't you have? 2/3. Okay. So if this is the inverse domain, what's the regular function range? All reals except what? 2/3. And what is the range of the inverse? All reals except negative 4/3. How clean is that? Let's go back to an easier one. Would you go back to number 7? What's the domain of 3 times the square root of x minus 1 minus 4? What's the domain of that? X has to be greater than or equal to what to make this real? Yeah, the inside has to be 0. So if this is 0, what will make it 0? X equal to what? 1. So anything bigger or smaller than 1? 2, 3, yeah, those will all work. So the domain of this one is x greater than or equal to 1, right? Now, I want to find the range, but before I find the range there, I'm going to find the inverse. So x is equal to 3 square root y minus 1 minus 4. Okay, so 3y, what should we do to both sides here? Add a 4? Sure. So you get x plus 4 equals 3 times the square root of y minus 1. Now what should we do? Divide by 3. Yep. So you get square root of x minus 1. Now I have 2 more things I have to do. What should I do to both sides? Square it. Good. And so you get x plus 4 over 3, quantity squared, equals x minus 1. So the only thing I need to do is to add 1 to both sides. And I'll have, this should be a y, my y. Now this is weird. What's the domain of this one? Little tricky here because this thing could be all reals, and we're going to talk about square root and this domain and range. It's a little bit different, but here's what I'm trying to get at with this. Would you highlight this and this? Because we're going to do something kind of weird here. Not weird, but just kind of different. I'm going to take f of x, and this is f inverse of x. And I'm going to do f of f inverse. I'm going to do something kind of strange. I'm going to write this 3 times the square root of x minus 1 minus 4. And I'm just going to get rid of some of my pictures here. They're cool, but they're kind of in my way. Okay. What do I put in for parentheses of x? Instead of x, what do I replace it with? F inverse, right? So I'm going to put in x plus 4 over 3. This is going to be trouble. Squared plus 1. So I just took this inverse and I put it in there. F of F inverse. And what do you think this is going to equal when I'm all done? What's the square root of 8 squared? 8. What's the cubed root of 4 cubed? Or what's the 7th root of 8 to the 7th? 8. So if we take the inverse of the function, you're going to get whatever you put in the first place. So I'm going to be interested to see what this turns out. Do you see these ones canceling? Yep. So now I have 3 times the square root of x plus 4 over 3, quantity squared minus 4. Well, what's the square root of this squared? This. Good. So I'm going to scratch this out. And what's 3 times x plus 4 over 3? 3 times x plus 4 over 3. What happens to the 3's? Cancels out. And so now I'm left with x plus 4 minus 4. And what's that equal to? X. You mean to tell me if you take f of f inverse of x, you get x? It works. That was kind of messy, but let's do one more of these. Let's say f of x is equal to 3x minus 5. Would you find the inverse of that for me? Go for it. Find the inverse. I agree. Take them off, please. Thank you. So 3x minus 5, yeah. So you go x is equal to 3y minus 5x plus 5 equals 3y. Y is x plus 5 over 3. So you agree with that. How many got that? Now, I want this half of the room to do f of f inverse of x. And this half of the room do f inverse of f of x. And let's see what we get. The outside function you write first. 3 times x minus 5. And then you put in, for x, the inverse function. X plus 5 over 3. Do you see these 3's and then the 5's canceling to get x? Love it. But look what happens when you do it the other way. X plus 5 over 3, and this time I'm going to put in 3x minus 5. Well, the 5's are going to cancel out, and then you have 3x over 3. You're going to get x again. So you mean to tell me that both of these are equal to x? Yeah. Show you one more thing. Here's the graph of 3x minus 5. Here's the graph of x plus 1/3 x plus 5/3. Like that. When I did f of g of x, what did I get for an answer? Or f of f inverse of x? X. What did I get f inverse of f of x? What did I get? Y equal x. Is that an accident? That the f of f inverse? Here's the f of x. Here was f inverse of x. If you put them together, you get y equal x. Not an accident, I don't think. All right, good. And that's it for those problems.